Hi, and welcome back to 1.2 Common Factors and Multiples from Course 1A Singapore Math. I'm sure you had an opportunity to watch content video and independent practice for 1.1. I'll be regularly posting videos for different chapters, both content video and independent practice. So let's get started with the content video for 1.2. As you can see in this chapter, there are 5 things that we need to understand. Let's get started with the first part, that's identify the common factors of two whole numbers. Common factors, meaning what? It would be common in both the numbers or 3 numbers or 4 numbers, as many numbers as you have. We have already studied about factorization, prime factorization in first chapter, right? So let's do the common factors and we'll try to keep the standard numbers for all the subtopics that we have to learn under this topic. So that way we can make connection and understand the similarities and differences. So let's say these two numbers are 10 and 30. 10 can be written as 1 times 10. It can also be written as 2 times 5. Do we have any other way to write it? No. So we end over there. And let's take the next number. That's 30. 30 is 1 times 30. It is also 2 times 15. Also 3 times 10. It is also 5 times 6. There's no more way to express 30. These are the 4 ways that we could express 30. Now the next step is we write 10 here and we list down all the factors separated by comma. So we say 1, 2, 5 and 10. Same thing for 30. We say 1, 2, 3, 5, 6, 10, 15 and 30. So we list down all the factors over here. Now the next step, because we are doing common factors, right? We have to identify the common factors from 10 and 30. So if you look here, 1 and 1 is common in both. 2 and 2 is common. Now 30 has 3 but 10 does not. So it's not a common factor. 5 and 5, common factor. 10 and 10, common factor. Right? So what are the common factors here? So the common factors are 1, 2, 5 and 10. So this is how we find common factors. So first you find the factors, possible ways of writing them, right? And then you list down all the factors, circle the common factors, and that's how you get all your common factors. Easy to understand, right? You'll get used to it when you do the independent practice because you have lots of questions over there that will give you enough practice to master it. Let's see the next one, which is find the greatest common factor of two whole numbers. You have to find the greatest. Now here, these are common factors. What are we finding? What's the difference? These are common factors. This is the greatest common factor. Did you guess what it's going to be? Look at the common factors here. Which one is the greatest? 10, right? So that's what we have to do. So let's go and understand this process here. Now in your book, you have 3 methods to work on in this case. I'll show all the 3 methods, and when we do independent practice, we will keep using different methods so that you have enough exposure of each of these methods. So method 1. As we did in the previous case here, this is method 1 for GCF. So I'm not going to repeat the whole method. I will just take this common factors from here. This entire process is method 1. Okay, you have to do the whole process. So the common factors I list down here, which are 1, 2, 5 and 10. So I say 1, 2, 5 and 10. So this whole step that I did for common factors, I do it here. Now I'm going to find the biggest one, the greatest one, right? So 1, 2, 5, 10, which is the greatest number? 10. So that is my greatest common factor. So that's method 1. So if you know how to find common factors, the first method is done for you. because from the listed factors, you just have to circle the biggest one, the greatest one. Let's go to second method. Now, method 2 and 3 are something that we did in prime factorization. The same method, we have it here. So we write 10 and we start dividing, right? So that is 2 times 5. Remember this? Of course you do, right? Because you've done independent practice also. Now 2 and 5 are prime numbers. They cannot be further divided. So we leave it there. Next we write 30 here and we start factorizing it. 30 is 2 times 15. 2 is already a prime number. We take it down 2 as it is. 2 times. And we factorize this. 15 is 3 times 5. All of them are prime numbers now. So we are done with the factorization here. What do we do next? We write here 10 equals to 2 times 5 and we write 30 equals to 2 times 3 times 5. Now let's find the common factors. 2 is common, 5 is common. So we say 2 times 5, which is equal to 10. So that's your answer. So 2 times 5. So we circled the common factors and we multiplied them. We leave 3. We don't do anything with it. You will see what we do with 3 when we go to the other subtopic. So we write it there and it's done. Okay, so that's method 2. Now let's go and see method 3. How does that work? Method 3. It's again from the prime factorization, the same thing. So we write 10 here and we write 30 here. In prime factorization, since we took one number, we just did with 1, right? But here we are taking 2 numbers. So we write them together like this. We start with the smallest prime number, that's 2. And 2 goes in both 10 and 30. So we have to take the prime numbers that go in both, like the prime number whose multiple are both the numbers. Okay, so we start with 2. 10 divided by 2 is 5. 30 divided by 2 is 15. They both still have common factor, right? And that's 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. They both do not have a prime factor in common. Okay, don't say 1. 1 is not a prime number. The smallest prime number is 2. Since they both have nothing in common, we leave it there. And this part here, what we have, we multiply. So we say 2 times 5, which is 10 again. So do you see the 3 different methods? No matter which method you use, you'll always get the same answer. So these are the 3 methods to find greatest common factor. And I'm sure it is very clear to you now, right? Confident? Yes, that's good. Now let's go back to the next subtopic here. So here it's about identifying common multiples of 2 whole numbers. Look at it carefully. It's no more factors, it's multiples that we are talking about. Okay? So let's see how do we do it. We'll keep the same numbers so it's easy for us to compare. So 10. What are the multiples of 10? So it's basically 10 times 1, 10 times 2, 10 times 3, 10 times 4. You go on like that. So these are called the multiples of 10, right? And it goes on like that. We do the same with the other number, that's 30. So we say it's 30, 60, 90. It's just like 3 times table, right? And so on. Now here, because we are doing common multiples, we are going to circle the common multiples. 30 is the first one here, right? 40, 50 is not there. Then we have 60 and we go on like that, circling the common multiples. So this is called common multiples. The question would usually say, get first 2 common multiples, first 3, first 5. So you have to go accordingly. Now here I have only first 2 common multiples. So this is how you do common multiples. It's very easy. It's no more factorization. It's multiplication now. So common multiples is done. So that gives us an opportunity to go to the next one, which is the least common multiple. When you had common factors, you had greatest common factor. When you have multiples, you have least common multiple. So the smallest one. Okay. So the first method is based on this. So I'm going to take the common factors from here and explain you further. So method 1 here, and we write common multiples. From this, we know the common multiples are 30, 60, 90, right? It will go on like that. So let's list them here. 30, 60, 90, and so on and so forth. Now the question is least, the smallest. And which one is the smallest here? 30. So the answer is 30. So it's based on this method. So if you understand this, the first method is already done. So method 2 here now. We are going to use this, right? So I'll just copy this part here. 10 equals to 2 times 5 and 30 equals to 2 times 3 times 5. So I need to first find the common factor. So that's common. This 5 and this 5 is common. So I will say 2 times 5 and then I take the uncommon factors from both. Now from 10 we don't have any, but if there was any other factor, we would take that down. So the uncommon is only 3, so we multiply that 2. That's the difference. Do you see? It's just 2 times 5. This is 2 times 5 and that's common factors, and we also take the uncommon factors and that makes it 30, right? 2 times 5 is 10. 10 times 3 is 30. So this way you can simultaneously compare how this process is working, how these methods are similar and different. So if you just take common factors, you're getting the greatest common factor. If you take common factors as well as the uncommon ones, you're going to get the least common multiple. Okay, and the last method, same as it's here. Let's see, 10, 30. I'm going to do this because there's little difference. We start with 2, so that's 5 and 15, right? Now, we said in this case we took only common factors, right? But here we'll also consider uncommon factors. So we go for the next prime number, which is 3. 5 divided by 3 will get remainder. So we don't do that. We leave 5 as it is. 15 divided by 3 is 5. Now both are 5. So we start with 5 here. Okay. So we multiply this one. So that's 2 times 3 times 5, which is 30. Right. So no matter which method you employ, answer is going to be same. See and understand how this is working. In first method here, we had common factors and we had common multiples, right? So common factors come from this process and common multiple is from this process. In method 2, we are doing the same process, right? The only difference is here we are taking common factors and here we take uncommon as well. Method 3, again the same process. Only common factors we use. Here we use common and uncommon both. And we get the answer. Understood how it works? The reason why I took the same numbers and I did this method adjacently side by side so that you can compare and understand the similarities and differences. Now we go here. The last part is this one here. Use the greatest common factor with the distributive property. So this is what we are going to do with distributive property. So let's take the same example here. So we say 10 plus 30. That would be your question, okay? Let me write it here. 10 is 2 times 5, right? And 30 is 2 times 3 times 5, right? From here, you take that. Now we circle the common factors. What's that? 2 times 5, right? So GCF, the greatest common factor is 10, right? From this method that we have here. So we take that 10 out, make brackets here, and in that bracket, now 10 divided by 10 is 1. We put plus sign as it is. 30 divided by 10 is 3, right? So this is how we solve this. Even if you don't do that, look at this number here. Anything is left? No. So we write 1 there. From this, what's left? 3. So we write that 3 here. So whatever is left, say for example, in this case here, we had extra 2 also. Then we would do 3 times 2, and instead of 3, we would write 6 over there. Okay. So this is how it works. With this, we have done all the 5 subtopics from this chapter. And as we do independent practice, you will be more confident because you will do lots of practice there. So we shall meet in independent practice video. Until then, keep watching this again and again so that your concepts are very clear. Have fun. Bye bye.